Ladies and gentlemen, as we are about to start, may I request all the participants to kindly mute your audio to avoid any interruption. Thank you very much for your kind cooperation. Thank you once again. Good morning, distinguished guests, speakers, and delegates. In the continuation to the conference, I would like to welcome you all again in this second day of mega event of International Crop Science Conference and Exhibition ICSCE 2020. As the pandemic has changed our lifestyle and so also our way of doing business. Like other sectors, the agriculture has also not remained untouched. However, the current situation has also provided a number of opportunities and hope. In the first presentation today, we will learn how COVID-19 will shape agriculture in 2021 from Mr. David Fabrota. Mr. Fabrota is Editorial Market Development Director for Mr. Media Worldwide's Global Precision Initiative. He is editor of Agribusiness Global and contributor to Crop Life. He is an award-winning journalist in several industries, including hospitality, veterinary medicine, human health care, golf course maintenance, and has more than 10 years experience in agriculture. So I request Mr. Fabrota kindly present. Mr. Fabrota, please.
Hello, everyone. I'm David Fabrota with Agribusiness Global and Precision Ag. On behalf of our staff and all of Meister Media, I'd like to wish you a happy new year filled with health and prosperity. I'd also like to thank PMFAI for continuing this forum. It's still important for us to meet and learn, and I appreciate their dedication to this important venue into 2021. We're discussing a little bit today on what everyone is discussing, is how COVID-19 will shape agriculture in 2021. We've had some slight impacts thus far. So my crystal ball, of course, is just as cloudy as everyone else's, but I will try to piece parts of the demand picture into place so that we can have some sort of guide as to what we can expect going forward. So in this presentation, I'm going to cover ag investment in response to COVID, focusing on infrastructure, planting intentions for major crops as a barometer for future demand, import-export changes for major commodity crops, retailer buying intentions for fertilizer, seed, and crop protection products. We're basing this on a North America survey from our sister publication, Crop Life. I'll try to spend most of my time on those data points and kind of go through these first few points rather quickly so we can spend the time on what I think many of us are interested in. And we'll end with some consumer demand shifts and their impact on production systems. COVID disruptions so far have been largely localized and at the national level. National funding and intergovernmental agencies have helped producers and distributors make food more available in homes. So that was the first wave of investments into COVID, as production systems largely in the beginning were unaffected, but then they became a little bit more affected as lockdowns began to occur. We'll look at consumption shifts to in-home demand, the possibility of some worker shortages as new variants are starting to spread around the world, and ocean freight, becoming a little bit more difficult to secure and prices increasing fairly significantly in recent months. We expect that to continue to occur into 2021. So a very quick look at funding and investment. The World Bank is deploying $160 billion in financial support through the end of the year to help more than 100 countries protect their poor and vulnerable, especially smallholder farmers. They're also investing in infrastructure projects that we'll take a look at shortly. Other NGOs and governments are investing in infrastructure as well. This is just one example from the Global Agriculture and Food Security Program, $54 million in ongoing public sector projects. This, of course, is infrastructure. And the interesting thing about, or the exciting thing about the investment in infrastructure is this is likely not a short-term investment. This will continue to bolster agriculture production and distribution after we have gone by the worst of the pandemic. So just some examples of that, the World Bank investments of $100 million to shore up local food production, strengthen critical commercial food supply chains, and provide short-term employment in rural areas where there might be a labor shortage because of sick workers or of lockdowns. Again, the exciting part about some of these projects is that they will hopefully not be short-term projects, but continue to bolster agriculture sectors going forward. Similar project in Bhutan, where food distribution is shifting from eating out to eating at home. And they're also financing beyond the initial food security elements and looking at medium-term projects to bolster inputs and irrigation. So we're talking about microfinancing that can help smallholder farmers access the inputs we need. Similarly, in Kenya, we're looking at ag investments, credit extension, and input supply programs. These are microfinancing mechanisms in which smallholder farmers can access seed, fertilizer, crop protection to insulate themselves from any disruption they might have for volatile commodity prices, lower production, and things of that nature. A lot of sustainable agriculture projects are being invested in around the world, looking at logistics, looking at maintaining exports for important crops that national economies rely on. Rwanda, obviously with its horticulture crops. In Kenya, the same crops are important for export to Europe. In Senegal, we're looking at mitigating negative impacts of the pandemic while creating more resiliency in supply chains. So this has a lot to do with bolstering retail channels to allow them to buy the inventory that they need to get that at the farm level during planting season. Here looking at the U.S. COVID relief program. Clearly the United States is investing a lot into its agriculture sector amid COVID, and to a great degree corn, soybeans, and wheat, to a lesser extent cotton and other crops. We think this funding will continue through 2021. This is a look at just pure coronavirus relief package. These are additional supplements given to agriculture producers. Another sector that's been hit rather hard has been in the livestock sector. So as people started to return home amid lockdowns or other situations where they were at home, they started to stockpile food. But not all food was stockpiled evenly. We saw increased stockpiling of pastas and rice and really grain crops that were highly storable and also cheap. More expensive animal proteins took a hit. And this was exacerbated by the closures of restaurants, the closures of schools, where a lot of those products traditionally were hitting the supply chain. So we've done a lot with funding distribution to alter the distribution of that food from institutional consumption to home-based consumption. And we're continuing to see a lot of that. Beef has always been a luxury in much of the world, and it might have taken the biggest hit around the world. Chicken and pork to a lesser extent, but still saw decreased consumption from home-based systems. In the EU, we're seeing loan guarantees, state aid, and emergency assistance from rural development funds. And similarly, they are ensuring food security, ensuring export crops, although to a much greater extent. Europe is expected to export less wheat and less other commodity crops as they're bolstering their local food security and creating more investment opportunities in their current agriculture systems. One more notable development in the EU, we're seeing the rescinding of product bans on an emergency level for some producers. So that's good news. As we know, regulatory will continue to shape the way our products are demanded around the world. But at least for the recent ruling on neonicotinoids, those products are going to be made available to producers on an emergency level basis. And that could be the initial domino that might open the door for additional chemistries to be used in those markets again. Although we cannot, we can't emphasize the importance of the new Green Deal and some of the strategies to mitigate chemical fertilizers and crop protection products through 2030. So that will continue to persist, but a tiny light in 2021. So now I'm going to shift a little bit to demand dynamics. We're looking at the most recent USDA World Agricultural Supply and Demand estimates. This is something that comes out periodically. These are the most recent numbers from January, and it's giving the planting intentions for major commodity crops around the world. And some of it is mostly good news. Commodity crops are at all-time low stocks and somewhat lower production, and it's going to push prices up. And the production is not low enough where it should affect inputs too terribly much. So looking at wheat, we're looking at smaller supplies, increased consumption, higher exports, and again, reduced stocks. Supplies are lowered about 1.6 million tons, mostly on reduced production in China and Argentina, but we're seeing increases in Russia and heightened production still in Ukraine. Projected global trade raised fractionally. We're looking at higher exports for Canada, EU and India, offsetting the reductions for Russia and Argentina. So this is well, I'm looking at these slides as kind of what's projected and then maybe a near-term effect. So the cause of planting intentions and then the effect it's having on the marketplace right now. This is the trailing 29 weeks of China wheat reserve auction prices. And we're seeing a volatile price increase for wheat. Reportedly, most of the reserve wheat was bought by feed makers, So presumably this is attributed partly to the increased pig stocks. As we know, pig stocks were decimated in China for the last 2 years. They're aggressively growing that pig population again. As a corollary, corn prices in China are at a record high, and hog production is greater than expected. So there's also a lingering fear that new outbreaks could disrupt part of the access to some of these feedstocks, not only in logistics, but in some ways the harvest. Looking at soybean production, it's lowered 2 million tons. This is largely from Argentina and somewhat Brazil. We're looking at global soybean stocks being lowered, and in some cases, in some countries, some of their lowest stocks in recent memory. So that being the cause, we're looking here at the big 3 soybean exporters: Argentina, Brazil, US. They account for 93% of the world's soybean exports. The first quarter is estimated to be up from a year ago. You can see the dynamics changing between the last few years being lower US exports. That's largely due to trade negotiations with China, and Brazil stepping in, and Argentina to some extent to fill the demand from Asia. This in 2020, we saw a rebound, and we expect that rebound to continue, and to consumption to continue on that upward trend in 2021. Coarse grains, notably corn, for 2021 is forecast down 3.9 million tons. Outlook for lower production and consumption in smaller ending stocks. Corn production, there's some fear or some estimated lower harvest in the early planting for Argentina and Brazil. That's being harvested now. And they did not get the rain that they hoped for the early planted corn. For exports of those crops, major changes include reduced corn imports for the EU, for Mexico, for Iran, for Vietnam, and some of those offsets coming from China. Corn ending stocks are lower, similar to soybeans, similar to wheat, and that is expected to bolster prices. And what we're looking at longer term in this cycle is the market meeting the demand of these lower stocks, in some cases the higher consumption, where we'll see acreage increase. In the US, they are predicting acreage increases in both corn and soybeans. That's going to drive consumption of those inputs. So here we're looking at the short-term effect. We're seeing price spikes per metric ton. Major corn exporters had seen a reduced stocks to use ratio toward the end of the year, and it looks like it's pushing even lower now. So higher global use, lower production. It's going to push that stock use ratio to 7%. That's a projection. That would be a record low if we hit that projection. And corn prices are projected to go up on the metric ton for feed. We're looking at similar situations on the Chicago Board of Trade for all major commodity crops. Stronger prices are good, especially this time of year as the Northern Hemisphere looks to apply optional fungicides. There's always a cost, an ROI equation that farmers are studying that might encourage them to apply some discretionary fungicides late in the season if that price remains strong. Rice has been strong for the past year, largely from what I said earlier with the stockpiling of foods. Stocks were reduced, prices went up, and producers have been capitalizing on that for the last year. Consumption has increased, will continue to increase throughout 2021 as we don't see any major changes to the way consumers or where consumers will be eating their food. So continued lockdowns, a shift away from eating out and dining out of home back to the home will continue to bolster some of those prices and production trends to meet the demand. So I hope that was a fairly positive picture on how cropping trends and production systems will insulate most of the crop inputs from any volatility. What we're looking at now is the most recent CropLife 2021 Buying Intentions Survey, and this is where I want to spend the majority of the time here. This is an annual study. I'll make this, PMFAI, I think will make this presentation available, and it's linked and you can read it in its entirety. This is an annual study that we talk to US retailers and determine what their stocks look like and what their buying intentions are going to be for the coming year. So in this first category, we're looking at fertilizers, dry and liquid. We're looking at micronutrients. We're looking at specialty fertilizers, and then additives and enhancements. And what we're looking at is a fairly positive picture. In 2020, we had a fairly full value chain that was inhibiting the large-scale volumes from moving through the value chain because many retailers were stocked up. That drove prices down, and many retailers were unable to capitalize on those lower prices because they held higher priced inventories. This sounds very familiar. I know we went through a similar situation with crop protection. The good news is retailers are buying again. They used up a lot of that oversupply. They started to weed that out throughout the year, and farmers, due to good weather, had opportunities to get out in the fields and apply more fertilizers, both at the beginning and at the end of last year in the US. So obviously this is weather contingent. We're praying for a dry planting season and a dry post-harvest season so farmers can get those products onto their field. Dry fertilizers and liquid fertilizers, almost 2/3 of retailers are saying they will buy more than they did last year. Micronutrients are also on the upswing. Some of this could be due to not much fertilizer being spread in the 2019 season because of extremely wet conditions. Farmers were barely able to get their field or their crops in and out of the fields, let alone discretionary applications of things like fertilizers in the spring and in the fall. So good news on that front. For crop protection products, we see a very similar, a similar situation where we had a lot of supply in the value chain. There wasn't a lot of movement due to full shelves. And as we saw prices dip in 2020, there still wasn't the movement of products through the value chain that we thought we'd see. That's starting to change. It looks like retailers have used a lot of that inventory, and close to 2/3 are saying they'll buy more fungicides and herbicides than they did last year. About half are saying that they'll buy about the same that they did last year, which is also positive. Very small levels of decrease for all categories. Insecticides look to be taking a bit of a dip. We had kind of lower pest pressures in the US, so there's still some supply in that value chain. Adjuvants are becoming more important for things like dicamba, where we have required adjuvants to lessen the volatility of that AI. And we're starting to see some of that shaking out, but about half saying they're status quo, and about half saying they're going to be buying more of these products. This looks good for crop protection, and we'll continue to see increased applications of these, especially if commodity prices for those discretionary late season fungicide applications are being generated through higher commodity prices. So for seed and seed treatments are in this crop protection part, where we're seeing a pretty sophisticated U.S. market, but I see, seed treatments in other parts of the country or other parts of the world starting to increase, especially for some BT crops. So in seed, again, we're seeing in terms of the planting intentions from the USDA and the FAO, we're seeing heightened corn and soybean investments. So in response to lower stocks and heightened demand, we're going to continue to see some of the major AIs that are parts of our portfolios continue to prosper. Wheat looks fairly on par with 2020, as with conventional fruit and vegetable seeds. Equipment is an interesting corollary to what we're going through as precision agriculture technologies continue to expand, and investments you would expect to be a little lower in a down market. So as we're straddling a recession or holding our breath to see exactly what kinds of economic fallout we're going to have in 2021, we have equipment purchasing a little bit on its heels, and that's expected. This looked very similar in 2020, but what's notable here is chemical and fertilizer storage. We talked about the glut that was in the supply chain, and we saw retailers and distributors unable to capitalize on the lower prices that began to manifest in 2020. So they're taking that as an indicator that they need more storage. That new capacity could help grease the skids for additional movement in some of the major product categories, especially for herbicides, and as well as dry and liquid fertilizers. The other category that is ticking up, almost a third, plan to spend more on application equipment. Now, traditionally in the US, those are tractor sprayers, but increasingly they are alternative precision application methods. So we're talking about the possibility of drones. We're talking about smart sprayers. Some of these are built into existing infrastructure. Some of these are new investments. So as we start to see the increased technification in the US market, we're going to continue to see that technification in other markets as well. We're seeing, for example, increased UAV activity in Asia, where fall armyworm is a pest, and the over-top application is a more efficient application of those insecticides versus backpack sprayers, so that we can get on the top of the tassel and be more effective on that pest. And finally, we're going to wrap up just looking at a little bit of what we have been talking about with this production shift. How is COVID affecting agriculture? In reality, it hasn't a whole lot. It was deemed an essential industry. We were fortunate enough to have, during the first lockdowns, most of the planting done by the time March rolled around. In the Southern Hemisphere, it was harvest time. So it didn't really seem to affect too much of the logistics at the production level. Now, there were caveats to that. There were sick workers who might have not been able to get all of the bananas or pineapples out of the fields in plantation type crops. But by and large, it wasn't affected as much. Where it was affected was in the distribution, in the processing and distribution, as people went to more home-based consumption. And what we're looking at here is data looking at forward-looking 2021 sentiment of consumers. And as you can see, there isn't a lot of sentiment moving toward going back to restaurants. I think people will go back to restaurants. I don't think it'll be to the same degree. So we have to understand how that might affect what producers are going to do and how they're going to be consuming inputs on the front end for us. In addition, food is getting costlier. So while those disruptions were minimal, there was an increased cost of distribution, and there was increased demand on the major commodity crops, which in turn put more pressure on food prices. We see food prices increasing around the world. And what that means is there'll be continued investment into food security initiatives. So some of the funding that we're seeing in 2020, a lot of people are wondering, will that funding continue? And I think it will. And it's important to recognize too that although there's a vaccine being distributed, it's going to take a long time to vaccinate 6 point something billion people in this world. The other contingency is that we have variants forming in various parts of the world. Those variants eventually will outcompete the vaccine. So we're in an arms race with this coronavirus, and it will continue to affect 2021 and likely beyond in the same way it affected 2020. So I'd be remiss if I didn't talk about some other demand factors influencing 2021, invasive species, heightened need for targeted insecticides in Asia and Africa for fall armyworm and locust outbreaks that are going to continue. Logistics, continued congestion at the ports, less ocean freight traffic is creating longer lead times for product shipping. This is going to encourage buyers to purchase products with anticipated demand for the next growing season. This could potentially lead to a boom-bust dynamic, very similar to what we saw in 21, where supply chains were full, but economies were ramping up their production systems, and there was very little movement from the manufacturer level into the supply chain. So this boom-bust dynamic must be something all of us are planning and insulating our businesses from. And of course, regulatory scrutiny, regenerative agriculture, sustainable production, and technology adoption is going to continue to incrementally erode crop input volumes around the world. I didn't talk at all about biopesticides or biofertility products because I know Mark Trimmer is here discussing that in depth. So these are a couple other macroeconomic issues that inevitably will affect COVID. I'll do my best to answer your questions. I hope there was something useful in this talk, and I will look forward to any insights you might have and questions you might have. Thank you.
Thank you very much, Mr. Fabrota, for your very informative and excellent presentation. Mr. Fabrota has highlighted the various disruptions like shortage of agriculture labor forces, increase in ocean freight, shift in food consumption pattern, etc. during the COVID period. He made us acquainted with the various support being rendered by the government and intergovernmental agency in different countries. His presentation based on USDA on world agriculture supply and demand with detailed analysis is quite helpful for the policy makers. Thank you, Mr. Fabrota. May I ask participants to ask only 2 questions? Delegate may please give your name and company followed by the question, and it should be very precise. Questions from delegates. Any questions from delegate side? If there is no question, we move to second presentation of the day by Dr. Wayne Tan, Overseas Marketing Director, Yongnong Biosciences Company Limited, on current changes in agrochemical industry in China. Dr. Wayne has background of chemistry with PhD degree from Chinese Academy of Science. He has been working in Chinese agrochemical industry for last 10 years and ever taken the various roles including research and development leader, business development manager, and global marketing director in Chinese leading agrochemical companies such as ICSCE and Red Sun. Presently, he is Overseas Marketing Director of Yongnong Biosciences Company Limited, that is a leading agrochemical company based in Hangzhou, China. Dr. Wen is going to talk about the changes in agrochemical industry in China. I request Dr. Wen to kindly present. Dr. Wen, please.
Good morning. Good morning, everyone.
Good morning, sir.
First of all, thanks PMFAI to give me this opportunity making this presentation. Before my presentation, I would like to spend 1 minute to briefly introduce myself. My name is Wayne Tan. My background is a PhD of chemistry. I used to work in a pharmaceutical chemistry company from 2008 to 2011 as a research scientist. And in 2011, I joined the agrochemical industry in China. The first company, the CAC Group. I took different roles in CAC. From R&D, business development, and marketing roles. In 2019, I joined Red Sun as a marketing director, and in 2020, I joined Yongnong Bioscience as overseas marketing director. You know, as you might know, Yongnong is a Chinese leading agrochemical manufacturer with a leading position on specific products, especially for the non-selective herbicides like dicot, glufosinate, and L-glufosinate. That's one thing to mention is last year in 2020, Yongnong Bioscience has successfully commercialized L-glufosinate in China. And to talk about the current changes of agrochemical industry in China, there is one thing we have to talk about first is the COVID-19. because I believe the COVID-19 is impacting everyone's life in every country. And so I would like to start from the current situation of COVID-19 in China as the first part of the presentation. As you can see from this map, this is each province of China, and there are different colors for different provinces. The deeper color means more existing cases. As you can see, there are 11 provinces. The color is white, which means 0 case existing in those 11 provinces. And there are 16 provinces and cities, so less than 10 cases existing. So in the whole country, the total existing cases updated on December 3rd of 2020 is 1,370 cases. So except for those existing cases, another number is also important, which is the emerging new cases every day. So here, the above chart shows the confirmed new cases every day, including domestic cases and imported cases. And the below chart shows only imported cases. As you can see, starting from January, the emerging cases every day can reach 10,000, the maximum. But after March of 2020, it dropped to 40. And then from time to time, still some cases emerged. So sometimes a few cases, and sometimes 20, 30 or 80 cases every day. And when compare with those imported cases, you will see after March of 2020, the imported cases contributed most of the existing cases. So in a summary, we can say the overall situation in China has been controllable since March of 2020. So as a result, the CCPIA has successfully held the ACE exhibition in October of 2020. And of course, there are some foreign visitors, they cannot join this show, but many, I think all the Chinese agrochem companies joined the meeting, just like it did before. So to summarize the current situation of the COVID-19 in China, I would like to say in China, the COVID-19 has not disappeared, still existing. And it might exist for another 1 year or 2 years. The people need to get used to them, but it has been well controlled. It has very little impact on the daily life. So after the introduction of the current situation of the COVID-19, I would like to share some data to explain the impact of the COVID-19 on the economy and also on the agrochemical export. For the impact of COVID-19 on economy, as you can see, this chart is a quarter-on-quarter growth rate of the GDP from Q1 2019 to Q3 of 2020. As you can see, the GDP growth rate in Q1 of 2020 dropped dramatically to -10%. However, it has rebounded to 11.7% in Q2 of 2020, which means the economy has gradually recovered in Q2 and Q3. This slide shows the agrochemical export from 2011 to 2020. But for 2020, there are only 9 months from January to September. But as for the export volume, which is showed as the column in this chart, as for the volume, you can see the export in 9 months of 2020 has reached the volume of the whole year in 2019. So I would expect the whole year export in 2020 will reach the record high in the history. So which means in 2020, the export volume of agrochemicals increased a lot, at least 20 to 30% compared with 2019. And as for the price index, as you can see, the price index reached the record high in 2019 because of the environmental protection inspection happened in the past few years. So in 2020, with the growth of the volume, actually the price is going down to a more reasonable price level. Also, we can compare each month, the export volume for each month of 2020 compared with 2019. As you can see, from March to September, the export volume of each month in 2020 increased a lot compared with 2019. Only in February, the export volume in 2020 is less than 2019. It's less than about 10%. So if we only count 9 months from January to September, the export volume in 2020 has increased 30% than the same period in 2019. It's a big increase for the export volume. So to summarize the impact of COVID-19 on economy and also on the agrochemical export, we can say it has a significant impact in Q1 of 2020, but it is followed with a strong rebound in Q2 and Q3. Then we can talk about the other aspects which are also impacting or changing the agrochemical industry in China. So to summarize the other aspects, I would use 2 keywords. One is the M&A, the other one is the relocation. So in this slide, I'm trying to list some important M&A cases recently happened in China. As you all know, Syngenta Group was set up in 2020 with the merging of the Chem China and Sinochem, and to build up a giant agrochemical company in China. And also, Adama acquired Huifeng, and UPL is going to acquire Yanhua Yongle, which is one of the leading formulation and distribution company in China. Also, the merging of the Sino-Agri Leading with Renaissance. Renaissance overseas business is also a big merging. And Li Min has acquired Hebei Wiyong Renaissance to be sold to a state-owned company. So there are also many other cases. It's happened or is going to happen in near future. But I would say there will be more joint companies and vertical integrated companies will emerge in China as a result of the merger and acquisition, will lead to the concentration of the agrochemical industry in China. And the other keyword is the relocation. Actually, when I made a presentation for the ABG 2 years ago, I have introduced about the environmental protection inspection in China, and the inspection resulted in the relocation of many agrochemical companies or manufacturers from east to west. So in this slide, there are two charts. The left one is the output of agrochemicals in 2019 in different provinces. So as you can see, the top 5 provinces for the output of agrochemicals are Jiangsu Province, Sichuan Province, Zhejiang Province, Shandong Province, and Hubei Province. So you can see most of the volume, the output of agrochemicals are still concentrated in east part. That's the total output. But when we have a look at the output growth rate in 2019 compared with 2018, you will see the top five highest growth rate province are all located in north part and east part. As you can see, Guangxi province is west of China, Jilin is north of China, Hebei is north of China, and Inner Mongolia, Sichuan province, and Ningxia province. All those are west part or north part of China. So which means the output growth is more concentrated in northwest of China. And also, there are more than 20 billion RMB to be invested in Ningxia, Inner Mongolia, and the Qinghai provinces. So as you can see, in the coming 2 to 3 years, lots of projects will be constructed in northeast of China. So that's the part of the whole relocation plan for agrochemical industry in China. So this slide gives more details about the relocation. As you can see, this chart is for the central provinces in China. So for each province, you will see the investment for the agrochemical intermediates and agrochemicals. A big volume will be invested in those provinces. And this chart is about the provinces in northwest China. So as you can see, for Ningxia province and Inner Mongolia province, will be huge number of the big capacity of agrochemicals and intermediates will be constructed in those two provinces. And also during the relocation plan, most of the companies they are doing the upgrade of their process as well. For example, they are doing the clean process to replace the traditional process, and also the upgrade of the facility to reduce the labor cost. Use more automatically controlled process to minimize the labor cost. So, as you can see, with the impact of the M&A and also the relocation, you might be curious, how was the performance of those agrochemical companies in China? So to give you a more clear picture for the performance, I selected 12 public agrochemical companies and picked some key data for the performance from their annual report, and to explain how did the performance changes in the past 3 years. So the 12 public companies are Yangnong, Jiangshan, Li'er, Changqing, Guangxin, Liming, Haili'er, Sinda, Flag, Fengshan, Rainbow, and CC Group. And this is and I picked the revenue growth of those 12 companies and the net profit of those 12 companies, and also the net profit rate changes in the past 3 years. As you can see there, the combined data of those 12 companies shows their revenue increased year on year from 2017 to 2019. The CAGR is around 20%, and net profit also increased from 2017 to 2019, but the net profit rate increased in 2018, but decreased to 12% in 2019 because of the price of the agrochemicals dropped in 2019. So to summarize the whole presentation, I would like to say, first, the agrochemical industry in 2020 in China was not significantly impacted by COVID-19, and agrochemicals export will reach record high in 2020. After the environmental protection inspection in 2018, the relocation and expansion of many agrochemical companies is in progress. And the performance of leading agrochemical players have been growing in the past 3 years due to M&A and also capacity expansion of their key products. So, okay, thank you very much. If you have any question, please feel free to ask, and also welcome to communicate with us, with Yungnong, for any kind of collaboration or discussion. Thank you.
Thank you, Dr. Wayne. In fact, it's a very useful presentation you made today. We are very happy to know that the overall COVID situation in China is under control. Dr. Wain's presentation on changes are mostly positive, which have taken place recently in agrochemical industry. Dr. Wain's presentation on changes which have taken place recently in agrochemical industry in China was very useful and enhanced our understanding. Hope the update will help more and more business association with that country. Now, we will take 2 questions from the participants. To stick to the time, please. And as the speakers are online, kindly ask your question. Participants, please give your name and company details. May I request participants to kindly ask their questions? Yes, questions are there. Dr. Wain, it's visible to you?
Yes, I saw the question.
Okay.
So far, the CCPIT is still planning to have the CAC show in Shanghai this March. So far, it's not cancelled, and I think it will happen in March, since based on the current COVID situation, is not that severe, it's well controlled. So I think it will happen.
Would you like to take another question, Dr. Wain?
The second question, the rise in export volume and drop in price index. Yeah, I think first for the price drop, because if you have a look at the change of the price index in the past 10 years, the 2019 price index is the highest price. So it's the drop of the price index is just, from my understanding, is the price come back to the normal price level. So it's reasonable. And the rise of the volume, I think first, maybe 2 reasons for the rise of the volume. The first reason is the demand. Demand is strong. As you might know, in 2018 and 19, some unexpected weather happened in the United States, in Europe, and also the drought in Australia, many countries. So the volume for the volume in 2018 and 19 is kind of lower. So most of inventory has been digested. So in 2020, COVID came, and many, I think, governments and farmers have been concerned about the safety of the food. So they have a very strong demand for the agrochemicals. Therefore, I think that's one of the reasons why the volume has risen in 2020. And the other reason is also because of the COVID-19, the Chinese government has published some new policies to support the export of agrochemicals. That's the other reason to support the rise of the volume for export. Yeah.
Thank you, Dr. Wain.
You're welcome.
Now moving to the third presentation by Dr. G. Himasagar on how to select adjuvants to improve efficacy and rain fastness. Dr. G. Himasagar is in technical service and development specialist for Dow in Indian subcontinent. He has an MTech degree in chemical engineering from IIT Delhi and PhD in chemical engineering, a specialization in colloidal and interface science from IIT Bombay. Dr. Sagar has close to 9 years of experience in agro formulations and product development. So now I request Dr. Sagar to kindly deliver the speech. Let us hear from Dr. Sagar.
Good morning, everybody. I'd like to extend warm greetings to all the participants and the speakers. And I'd like to thank the organizing committee for giving me the opportunity to speak on this topic. Firstly, I'd like to introduce myself. I'm Dr. G. Himsagar. I'm the Technical Manager for Crop Solutions in Industrial Solutions, part of the Indian subcontinent in Dow. You all know Dow is a relevant player in agrochemical industry, providing solutions to various agrochemical formulations. Today, I'm going to talk about how to select adjuvants to improve efficacy and rain fastness. As you all know, we are a chemical supplier. However, our goal is to enable you to produce actives and formulation that enhance yield and make optimal use of agrochemical formulations. Today, I'll be talking about two case studies. Out of that, the first case study is on to enhance the performance of SE formulations. What you see on the slide is the various components or the functional additives of any agro formulations. In that, very specific for SE formulation, I'll be talking about dispersing agents. I have also highlighted some of the other chemistries we offer for different formulations, whether it is EC, OD, WDG, and WP, which includes various chemistry like anionic, non-ionic chemistries, and also in certain cases solvents and co-solvents to improve the solubility of the active, and also the thickeners in case of very specific SC and as well as for the oil case. The second case study which I'll be discussing about is a rain fastness additive. This is very specifically for after the formulation has been prepared. You need a polymer which will reduce the active wash off. So we are providing a copolymer which will be used for this case. Talking about the capability in Dow, we are globally present. We have close to 18 locations for different applications. We have about close to 3 or 4 application development labs placed out in what is shown in the map in Midland, Europe, in Mumbai. And we have close to 80 years of research applications with core molecules, which include surfactants, solvents for the agro formulations. Coming on to the case, in case if you want for any local support, I think we have a lab in Mumbai. What you see on the top hand side is the DITC lab placed out in Navi Mumbai. And we have different capabilities in the local formulation lab for crop defense. Out of that, we also work with EC, EW, SC, WP, WDG, and OD. Also, we do the stability testing for these applications. If you have any queries or if you want to do a joint development with Dow, I think we have local support. At the same time, we have support from other geographies where we can leverage those capabilities in this case. Coming on to my case, the first case which I'll be talking about is the SC formulation. SC formulations are more prevalent these days because everybody is moving from WP as well as to EC, where WP is more of a dust kind of formulation, and EC, where it's more of a solvent kind. So they are moving to water-based, where SC comes into prevalent. However, one of the biggest challenge with the formulation is SC formulation is its efficacy. When I talk about efficacy, we should also highlight on what are the key factors which contribute to improving the efficacy. One is the active, because depending on the active purity, its solubility factors also contribute because we are using SC formulation. The second important aspect and the key one is the dispersant. So what type of dispersant you should be using? Its structure, whether it is steric or electrostatic type of stability. And also in certain cases, the wetting agent also plays an important role in efficacy. The last but not the one in this case is the thickener, because thickener in certain places where if you are not able to select the right dispersant, people thicken the SC solution. That's one of the way of stabilizing solution. But however, in Dow, we provide right dispersant which improve the efficacy for SC solutions. However, the common challenges for SC formulations are low grinding efficiency, which is primarily due to whenever a grinding takes place, a new particle is created. That particle is not covered by the surfactant, thereby agglomeration happens. Another key aspect is the active with high water solubility. If it has a high water solubility, the agglomeration is also one of the common tendency. The next being the particle size distribution and stability and phase separation. These are both interconnected because the larger the particle size, settling will take place. However, you need much more better coverage of the particle with the surfactant. I have talked about the efficacy. The important factor which I talked about is the dispersant. So how do you select a dispersant? So one of the emerging trends are the polymeric dispersion, because they are big, large structures with comb-like structure or star-like structure. That's what we can see. We can design these molecules by either by molecular weight or its ion density or balancing the hydrophobicity and hydrophilicity. What you see in the slide is the linear type of comb-like structure, branch, star, cross-linked, and branch. So these are the different polymers which we have prepared. In this case, we are talking about electrostatic and steric hindrance due to the structural part. What we are talking about, we have designed two specific polymers, one being Power Block D205, which is a TER polymer, which contains 3 functional groups, which not only helps in dispersion, at the same time also separating the particle, thereby there is no agglomeration. The second being is a co-dispersant in combination with D205, which is a comb-like structure, which basically adheres onto the particle, at the same time not allowing the particle to settle, and a part of the polymer will be in the water phase. Thereby it stabilizes in the system. As I talked about the two polymers, Power Block D205 and 305, you can see a schematic or a specific example which we'll be talking about, which is imidacloprid. I've talked about two formulations. What you see is the formulation number 3 and 4. In general scenario, you use a EOPO block copolymer. When you add in combination with the D205 and 305, those systems are much more stable. So we have prepared two formulation 3 without a EOPO block copolymer and with a combination with EOPO block copolymer. What you can see is in this case, the particle size D90 is less than 10 micron. The viscosity is much more lower from a handling perspective. And also when we had done when we had prepared the samples and kept it for 2 weeks at 54 degrees, we can see the stability of these samples without any phase separation. We had done further studies for the similar sample which I talked about, where you can see the TurbiScan for formulation 3 and 4, where we had done the suspensibility studies at 3% in tap water. The TurbiScan was done at 1 hour and 3 hours, which was followed up. What we observed in 3 and 4, there was not much difference. So which also does suggest that if you use a block copolymer in combination with Power Block D205 and 305, you will get a much more stable system which can be taken forward. I'm also suggesting, in case of if you're using for alternative kind of chemistries, Power Block EM90 is one such of chemistry which can be used, which also helps in dispersion of the particle, having a lower particle size, at the same time controlling the viscosity. I've given an example for azotostrobin. You can use that as an example. For other specific SC formulation which you want to develop, you can share those details with us. We'll accordingly share the guideline formulation for your specific active. Just to summarize on the key findings for the two acrylic dispersants I'm talking about, this Power Block D205 and 305. When you use it, D205 and 305 in combination EO-PO block copolymer, you get a much more good formulation with longer stability. And these samples have been stable till 14 days at 54 degrees and for 50 days. Also, the acrylates in combination with EO-PO have known to be better dispersants because they complement both of them in terms of adhering onto the active, at the same time having a certain phase into the water system. Just to add to you the other kind of examples we have mentioned, so that if you are looking for certain other actives, we have also demonstrated that, but I haven't shared the results for these actives. But these are guideline formulations. If you want to develop for pyrimetazine and tafuzamide for SE formulation, the specific dosages where you can develop this formulation with xanthan gum as a thickener. I've given the example. If other than these actives, if you need other actives, we can work together in developing a formulation. I'll be switching on to the second topic, which is the rain fastness. Rain fastness is one of the common problem when whenever a farmer sprays an active solutions. There is a if there is a rain, the active there is a loss of the active takes place. So we have developed a copolymer which is called Power Block RF65. This Power Block RF65 helps in allowing the active to stick onto the leaf, thereby wash off of active is lower, evaporation is also lower, and more penetration of the active takes place because it stays more time onto the leaf. To talk about how does the mechanism of these Power Block RF65 looks like, you have to blend these Power Block RF65 with your active. So one, there will be slight wetting. It would be taken onto the leaf. But you can see the picture onto the slide where the sticker with the active will be adhering onto the leaf. Thereby, even if there is a rain, it will not wash off, and there will be enough time available. Even if there is a bigger rain, the active will pass on to the leaf, thereby starting its own action. So the adjuvant will not also help to penetrate and also will adhere onto the leaf, thereby improving the efficacy. So to demonstrate these, we have shown certain examples. However, just to highlight one point, that the Power Block RF65 are EPA registered adjuvants. So to give an example for mancozeb, if you happen to use mancozeb with Power Block RF65 with and without Power Block RF65, what we have done is we have done a lab simulation studies where we have created a platform with the active part over there and then simulated a rain for 1 hour and at a speed of 100 mm per hour. And then after that, we have measured what is the active content on the surface. What we can see is if there is no adjuvant, which is basically the rain fastness additive, there is a difference in the mancozeb retention on the leaf, which is 8 and 46%. But for other active, there is a slight, there's a 10% increase in case of pyroxylam and difenoconazole. In both cases, you can see 10% increase in the active retention onto the leaf, which also signifies that even if there is a rain, there is a more active onto the leaf, thereby the active will penetrate into the leaf. The next part comes is the drug efficacy. So the one part of drug efficacy is how much of the active has gone into that one. That reflects into the root of the system. So we have done a similar studies where we have done a root in which we have added to that, and the crop was corn. And then we have with simulated with and without adjuvant. You can see a difference of close to 3% in the bioassay, which also suggests that the efficacy is improving when we add RF65 as an adjuvant compared to the other cases. We have also done a field trials for these RF65, and we found that in case of field trial, the performance is similar to what we have observed in the lab. And we have done field testing for glucophosphamate 200 gram per SL for SL. And in this case, we have done for a crop of CK, where crop for indica. And in this case, we have observed that the performance RF65 is much better compared without an adjuvant. And similar trends can be observed what we have seen in the lab results. To talk about the product, so how do you handle this product? The product can be used for water-based systems. It can be used in two forms. Either you can add in can, or you can add in tank mix, where in tank mix you have to add it in 0.1 weight%. However, in can you have to add it at 4 to 8 weight%. This is a 50% polymer and 50% water content is there. It's a white milky emulsion. So you have to just dilute it, add it in the system in can, and continue with your studies. To summarize my work, whatever I've done it, one, I have highlighted on the efficacy of SC formulation, power block RF 205 and 305. The second being improving the efficacy by having the right adjuvant, which is the Rain Fastness additive. In this case, what we talk about is selecting right adjuvant. The compatibility of surfactants in pesticide formulation can be only achieved by using a right adjuvant. And we have a much more bigger product portfolio to demonstrate for different actives which can be done. Dow has many solutions for enhancing for other applications for your pesticide formulation, whether it's SC, WDG, OD, and any other cases. If you have any other queries, please contact my email ID mentioned above, and also you can contact me on phone. I'd be happy to answer your questions. Thank you very much.
Thank you, Dr. Sagar. In fact, it's a very informative and excellent presentation. I hope the participants have been immensely benefited from your informative and illustrative presentation. Dr. Hima Sagar's talk was very excellent and was very helpful, especially for formulations technologies. He explained beautifully the role of adjuvants with respect to desired properties of formulations by selecting right type of adjuvants, better and more efficient formulations with optimal use of active ingredient and could be developed. And this in turn will help the farmers to protect their crop more efficiently and increasing the agricultural productivity. May I ask the delegates to kindly put your questions. We can take 2 questions. Delegates, please be precise with the questions and share your name and your company name. Delegates, please. Dr. Sagar, are you able to, it's visible questions?
Yes, I can see that.
Okay, sir. Thank you.
Okay, coming on to the first question by Dr. Ritu Ahuja on the microplastic. Yes, in this case, we are talking about acrylic chemistries for RS65. Those do consider under the microplastics, but in this case, we are also coming up with the upgraded polymer where you don't have the microplastic issues in that case.
Is the second question also there, sir?
What's the role of pH? Adjuvant compatibility with active one hydrostability. Okay. Okay, coming on to the pH, yes, pH plays a very important role because all the steric as well as in case of electrostatic that plays an important role while stabilizing that. So in terms of that's the reason why in certain cases you have to have a combination of anionic and non-ionic because that will also help in case of there is a variation of pH to address that issue. Is there any study done on we haven't done that, but largely we try to cover most of the chemistries on the active family. But however, based on the fundamental understanding on the polymer structure and that, I think we can have a discussion offline and then we can suggest you some of the solution from our end. Because we are not a pesticide manufacturers, so what we do is based on the customer requirement or in certain cases, we target certain actives and then prepare those formulations. But if you have specific actives, we can definitely work on that, where you have crystallization in SC or you have viscosity issues, we can definitely work on those actives also.
Thank you, Dr. Sagar. Now moving to the next speaker. The next speaker is Dr. Suji Asiju. Dr. Suji is originally from Japan. He received his DPhil degree in chemistry from University of Oxford, UK. He is Chief Technology Officer, MOA Technology Limited, and has wide experience spanning agri-tech, biotech, and pharma sectors, Syngenta, GSK, Pfizer, Procter & Gamble, and Aztecs. He has held various leadership roles in research and development and authored many patents and scientific papers. Dr. Suji will speak on finding the next generation of herbicides with new modes of actions. As India, like other parts of world, is facing problems of weeds and handle the weeds management, shortage of labor, products being reviewed or partially banned or restricted for use of herbicide worldwide is around 48%. In India, the use of herbicide is about 16% of the total plant protection chemicals. Hope this talk on novel herbicides developed by MOA Technology Limited will enlighten an audience will certainly get benefit from his presentation. Dr. Suji, please.
Hello, can you hear me?
Yes, sir.
Brilliant. So thank you very much for your kind introduction and also for the invitation to talk today and to the organizers at the Pesticides Manufacturers and Formulators Association of India. I'm very pleased actually. And, actually, when I used to work at Syngenta, I had the pleasure of spending 6 months in India working in our site in Goa. And I had a lovely time in India, and very excited to be able to talk today. Unfortunately, due to COVID, I'm obviously not there as a person, and I would have loved to join there as a person. But please bear with me as I do my best to try to convey what we do at More Technology over this Zoom call. So More Technology, unlike some of the other companies I worked for in the past, is actually quite an early stage startup, and our mission is to find the next generation of herbicides with a new mode of action. And we like to think this is quite a lofty role because the last time a novel major mode of action, the biggest one that's probably come up was probably like that, the likes of HPVD is quite a while ago. So, at this stage in time, we don't actually have a commercial product yet because it takes, about 10 to 12 years to get compounds to market. And actually the company itself has been existing for 3 years. So it's still some of the early stage R&D results, but hopefully you may still find this quite interesting. Right. So in terms of changing slides, are you able to, am I supposed to change the slide on my end, or would you be able to change the slide to the next slide, please?
So you just prompt us, we will change. Yeah.
Okay, thank you. Right. So in terms of the content of my presentation, so I will talk briefly about MOA Technology and how it was founded. I'll very briefly talk about the herbicide crisis because I believe, based on the audience, that I don't have to probably labor this point too much. I will then also talk about our mission And then about our discovery platform, we have 3 in particular called Galaxy, Target, and Select. And then the type of strategy we take to use, buy, and purchase and acquire chemical input to our screening system. And then some of the downstream assays we do in the glasshouse. And then about a particular compound called MOA-XX1. And then sort of workflow in terms of lead generation and the chemistry strategy you have. And then just touch upon some of the things I've learned in terms of challenges, opportunities, and startups compared to my previous roles in multinational organizations. Next slide, please. So our organization was founded by Professor Liam Dolan and Dr. Champion of Plant Sciences at University of Oxford. It is privately funded by mostly a venture capital fund. We raised a seed round of 2 million, and we follow that with Series A round of 6 million. And we recently raised another round of 5 million. So we are very have the privilege of having very supportive venture capital and University of Oxford funding us through our growth trajectory. The more employees, as you can see, has been growing rather rapidly. And in 2018, we started off with 1 person. And yeah, we went to 15 in 2019 and grown to about 35 this year, basically. So we have a capital light operation still, with skilled internal staff operating proprietary platforms and then managing a global network of consultants and CROs. Next slide, please. So just to touch upon the herbicide crisis, I thought I would just leave it to just this one slide. It's just a picture of soya with Palm amaranthus pigweed growing in there in Arkansas. And you can show this is in the US, how difficult it would be obviously to for the soya to grow, but let alone harvest in such situations. And in the US, when you have these type of bad situation, you can imagine the huge fields in the US and big acreage looking like this. And farmer would then just quite often just resort to blow torching these, as they are glyphosate resistant and very hard to clear. Next slide, please. So the context is there is a resistance problem with herbicides. There are also some safety concerns, and there's also been, some notable news of coming out from the US about, litigation regarding glyphosate and the like. And there's also there's a public perception to combat with certain herbicides. And as I was saying earlier, there hasn't been a significant new mode of action for a very long time. So more technology would like to use our technology to try to make a contribution to try improve the situation and launch novel mode of action herbicides. And as I said earlier, we have 3 technology pillars: Galaxy, Target, and Select. And we have a new approach to herbicide discovery. And this leverages an emerging plant model, proprietary bioinformatics platform that we established within the company, and artificial intelligence and chemistry. Next slide, please. So in overall bird's eye view, our 3 platforms could be put sequentially from Galaxy, Target to Select, from left to right. And it sort of works in that sequential order. And this is because the Galaxy system is a high throughput screening platform where we are able to simultaneously detect herbicidal potency of compound alongside mode of action information, which allows us to figure out the most biologically novel and interesting compounds where we aren't able to figure out the mode of action, which signifies it could be potentially a new mode of action. And being able to do this high throughput up front is quite revolutionary, because usually customarily, in order to do mode of action detection is a separate step. And we have brought these 2 together and can do it in quite unprecedented rates. And once we have, the very few compounds that are both potent and potentially novel mode of action, we would put it into the Target platform to do mode of action elucidation. So this is where we're trying to figure out the exact protein the compound is working on, because Galaxy is a phenotypic assay where you are treating whole organism with a compound. And finally, once you have your protein target information to hand, you can use a Select platform, which is a mode of action specific screen on an in vivo system that allows us to then find new chemotype. And the interest there, again, is the fact that it's a mode of action directed screen that's in vivo, because usually mode of action directed system is in vitro. Now, our talk mostly about Galaxy today and a little bit about Target and hardly anything about Select. And that's sort of because this is how the platform is not only should be used in that order, but actually being developed by the company in this order. And our Galaxy platform is the most well-established and also patented, and I'm able to talk more about it. So please bear with me that certain things are a bit more sketchy. It's partly not because I don't want to talk about it. As being CTO and or in the R&D, I love to talk about it, but unfortunately, my intellectual property colleagues would probably get me into trouble. So next slide, please. So this is just to give you a glimpse of the type of data that Galaxy produces for us. So, we treat our plants in 96 well microtiter plates with our chemicals, and we are, testing about 40,000 compounds per month. And, to do this test, we require very little chemical, sub-microgram, and this has some various advantages, as you could imagine, if you could use small amount of chemical for the initial screen. And for every chemical and every compound tested, in these plates, you get about a population of these plants, at least 60 of these. And you can see an image of it on to the right on what some of these plants will look like. And, the great thing about our test is that we're able to simultaneously get data on the population level, at the cellular level, as you can see in the picture to the right, and then also at the subcellular level. So, if you look at the picture on the far right, you can see that the yellow shining element, those are the nuclei, and the red fluorescing things are the chloroplasts. Now, we also do some labeling of these organisms that allows us to also then study other subcellular compartments. And actually, we also take images at even higher magnification than shown here, so we can really study the subcellular effect. And we generate all of these data for every single compound. And it's very exciting because usually on a front-end phenotypic screen, let's say if you're doing on an Arabidopsis or bigger weeds and the like, it's not possible to look at population, cellular and subcellular all at the same time. The exciting element of this organism allows us to do this. And also actually it's still in vivo and biologically relevant system, because this is an actual whole organism with the usual meristem, photosynthetic tissue, and the rhizoids, the root system, and all of the relevant system for a plant is all there. Now, the middle graph is just a three-dimensional picture of the type of data we generate. So, we generate a lot of data, probably like 1,000 data point per compound, and you can imagine a huge number of columns and number of dimensions. But, just to illustrate the point on a slide, we have basically done a principal component analysis to squeeze that down into 3D. And then, even within that 3D, you're able to pick apart different mode of action, and different colors indicate, and the labeling indicates the mode of action of the type of chemical that falls into each category. So, as we screen new compounds, you could imagine mapping those results to this graph, and based on where it is, you'll be able to see what the mode of action is. But obviously, the most interesting compound are the ones that actually doesn't hit any of the sort of green or red or various no mode of action, but the sort of the lone star compounds sort of sitting in a random place far away from these clusters, and those are the ones we look further in through with our target platform. Next slide, please. So our target platform, as I said earlier, is a protein identification system, because obviously every organism expresses so many proteins, and if you dosing your chemical into an entire organism, there's no way for you to know at the beginning exactly which protein is binding, especially when it's one of those lone star compound. So what we do here is effectively a forward genetics experiment to figure out the exact protein that caused the problems through looking for resistance. And what's exciting within our context of our company is we have some proprietary bioinformatics and the organism that allows us to do this much faster than traditional systems, and also pinpoints the protein without having to do too many segregation analysis. Usually in a typical these type of experiment, it's very hard. Every organism end up with so many mutations that trying to figure out which mutation allows it to survive is hard to figure out. But in our system and in our pipeline, this can be done in a single generation at unprecedented rate. So this is again what's the exciting about the more target platform. And then next slide, please. And finally, Galaxy Select is the most loosely shown here, and it's partly because the most undeveloped. But we have done some proof of concept work here, and again, as I said earlier, it is an in vivo mode of action directed screening platform, and that's, as I said earlier, it's a bit of a contradiction in term, because usually, if you want a mode of action directed system, it needs to be an in vitro screen against a protein. We're doing it in vivo in a organism system, and that's what's the unique thing about it. And hopefully in future conferences and in a future opportunity to talk to you, I'll be able to perhaps show you more than a picture of a library, which is probably not that exciting, obviously. Next slide, please. So in terms of the chemical input to our Galaxy system to find novel chemical starting points, our strategy has generally been to go for diversity. So if you're trying to find a novel mode of action where you know nothing about, it's very hard to rationally choose chemicals you want, because naturally, rationally choosing means you predefined or pre-decide the protein you want to go after. We want to have a mode of action as a initial input, a mode of action agnostic method where we have the chance of hitting every single mode of action possible, and that is more about chemical strategy wise. You want to go the diversity oriented way where you try to based on 2D fingerprinting of chemicals and 3D fingerprinting, the most diverse shape. And because we can screen at high numbers, we believe we'll find the right key or right chemical that then fits into hopefully an exciting new protein that people haven't worked on before. But to supplement that, we also use certain filters such as herbicide likeness, which is very important to make sure it has the right physical chemical property, because it's not just good enough coming up with a ligand that interacts with the protein. In the end, we do need a commercial product, and ideally, let's say systemic and the like. And they're well published data on what sort of physical chemical properties required. And also, we will use things like molecular features that are come into play. And we would remove these undesirables, and these are public information about toxic chemical functionalities. You're not going to want to put in compound with an organomercury bond. I mean, that is an extreme scenario case, but there's also some subtle, more organic, normal looking chemicals that also still doesn't look good in terms of toxicity. So we do leave those things out too, because as I was saying earlier, we're trying to address safety concerns too. So we want to make the safest compound possible. We also look for novelty, obviously, and that's because we want to be able to patent these things. And we use APIs available from SciFinder to make sure every single compound we ever go after is always novel. And also what we'll do is we look for compounds that have some similarity to past hits if you want to improve those hits, especially the ones with novel mode of action. And in terms of the library sources, we access our library from synthetics and both natural products. And certainly for the natural products, you can buy the pure ones, but also mixture ones. And we access these through joint ventures and partners and non-commercial chemicals through our networks primarily in the UK for now, based on where we are. Yes. Next slide, please. So you have a hit from Galaxy, and the picture here is at the left-hand top. You have what our compound have done in Galaxy, and the image you have on the left-hand corner of that gray photo is what the control plant should look like, and the rest of the picture shows how it sort of destroyed that plant with our chemical. And at the end of the day, we are looking for a herbicide that works in the field, and the obvious thing you do in going from an early stage screen like a Galaxy to the field is to first test it on, let's say, Arabidopsis and Poa, and more well-established plant models in the laboratory, which we have done. And we were pleased to see that, once our compound goes into there from Galaxy, the potency there is very good. So the first arrow that says 0.3% indicates that when you bought random libraries, like completely randomly, in the hundreds of thousands, 0.3% of that is active. And that's kind of natural, actually, because as you can imagine, if you're just buying random libraries, mostly everything's going to be inactive. But the few that are active that Galaxy managed to pick up, which is a 0.3%, goes into this 2 weeds growing on agar, Arabidopsis and Poa. And what's exciting at that stage is this is a bit more traditional screen now, which is quite established. Those compounds, 0.3%, 50% of them are active on that system. And that was a very important validation for us because, at that stage, let's say if the protection rate was 0.3% again, it just means you haven't done anything. It's still random screening, actually, sort of level. So what we've done here is to be able to show that Galaxy works as a great way to find certainly plant relevant potent compounds that then can go into the glasshouse. And we test on 4 weeds at high rates, and that showed good activity at about 20% of the time. And then we'll do a dose response test. And then we will go into primary profile screening where we test against more weeds, about 12 of them, and the 4 major row crops: rice, soya, maize, and cereals. And you can see the progression rate going forward. And you can see the reason why it's very high is because we have a good set of chemicals feeding into it. And actually, we're just in the process of doing some field trials, and we're hoping to get some data out soon, so we'll be able to start talking about the percentage progression and how things are going well in the field. But that's again soon to come. Next slide, please. So this is the type of data that we generate for, let's say, one particular compound called MOA X1. I obviously renamed it from our usual MOA number. And just to give you a flavor of what the chemistry is like, the molecular weight of this compound is 300, which is reasonable for a herbicide, a log P of 2.5, which is again reasonable. And you can see the various other property that shows you that the compound is, a good starting point, such as Lipinski's rule. Although Lipinski is more for pharmaceuticals, but you can still kind of compare a little bit of information about it in an agrochemical setting to just show you some favorable property of a compound. And then this particular compound, as you can see, so the table on the right is the glasshouse results that's been summarized. So across the top is columns of weed names and crop names. So the block on the left is the crop: soya, rice, and corn and wheat. Those are the 4 columns. And then we got broadleaf weeds and grass weeds. And you can see on the second to left column the rate these compounds were tested at. And as you can see, the most advanced results is on the bottom row, which is 4 rows going from 1,000 to 125. So if you could focus on that, you could see that actually the numbers in the middle are the phytotoxicity, the amount of control these compounds are able to achieve against these plants. And you can see that this compound is having little effect on corn, wheat, and rice, and yet having activity on Amaranthus and Stellaria, Veronica solanum, and some level of activity in grass weeds. But for us, it was very exciting to see this because this is a hit straight from Galaxy and hasn't been optimized yet. So this is a chemistry where we are looking to optimize, and we've already filed a patent, and we are just now exemplifying the patent to find more and more exciting compounds from here. And again, this compound is actually in the field. Next slide, please. So, Galaxy provides a hit, and then after that, obviously, you have to go to the glass house, and then actually you have to improve the system. So this is just based on mode of action and the potency of our compound, the general level, high level strategy we take for our compounds on how to progress them and how to patent them. So, if you flow in from the left-hand side, as I was saying earlier, we buy diverse chemical libraries that feeds into a Galaxy system, where we look into potency and mode of action. And what the most novel, most potent, exciting compounds go to the glasshouse. And then in the glasshouse, there are, broadly for us, 3 scenarios. From the top, what you can get is a strongly glasshouse active, but known mode of action compounds. Now, if some of these are known mode of action and also looks like a very, very common mode of action, and where there's so many commercial products, like, if you find another urea or a triazine that is PS2, such as, diuron or atrazine, we tend to discard and not go any further in that area. But if it's a completely novel PS2 or a novel HPBD, things that don't look anything like existing compounds, we're still quite excited by it, actually. So we will follow that as classified as novel chemotypes. And we tend to patent this quite fast because, certainly these type of high activity novel chemotype compounds are of interest to many others. And we were looking to design and purchasing and synthesize compounds that then feeds back into the glasshouse cascade earlier on. And then we'll keep having testing cycles till we, find a commercial product. Now, the second scenario is where we have, from the glasshouse, strongly glasshouse active and novel mode action compounds. And, these are the real no-brainer. And we tend to heavily resource these, and we patent these immediately because they're of the most significant interest to us. And then finally, the third strategy is quite an interesting strategy in the sense that, you will, of course, still come up with weakly glasshouse active novel mode of action. And in our experience, actually, we see more of this than the sort of the no-brainer strong glasshouse active ones. And that's probably because, it probably makes sense, doesn't it? I mean, and the strong glasshouse active mode of action would have also been quite easy found in the past. And maybe perhaps most of those are being found already by, over the years of R&D that's been going on. But obviously the bottom one is a harder one to pinpoint. But, one good thing about there is, you can patent late because, it's harder to find those areas. But with Galaxy, the system we have, we are able to find such, nuanced and very subtle subcellular effect and the like. So we're able to find things that doesn't work the way it has done in the past. And then what we do there then is we follow that up by buying analogs and trying to do ligand hops from that to trying to get new chemicals that are handmade and actually not just simply purchased from libraries to target as new chemicals that then goes into optimization campaigns. And, this is actually a unique selling point, obviously, because, the reason why we could be quite successful with this strategy, using the Galaxy system in the more technology context, is because we're able to do mode of action upfront at such an early stage. Because mode of action elucidation and trying to figure out whether you don't know the mode of action is so resource intensive that usually, it's often quite, in a normal setting or big companies can be done quite further down the line once you've already established quite a lot of potency. But because our system, we are able to, on the tens of thousands of scale at the beginning, we're able to prioritize some of the mid-tier to weaker compound in the glasshouse and show which one of those are potentially novel mode of action, and then focus on that. So it's a method of prioritization that is open to us. That's not easily as available unless you have access to the Galaxy system. And again, the great thing about that strategy is actually, output from that we can patent late, which also obviously means, because herbicide R&D takes like a decade and more, you don't want to use your precious 20 years of patent life, spending most of it in chemical optimization. But sometimes you just have to patent early because others can fight it and it's competitive. Next slide, please. So before I close, I thought it might be worth just touching briefly on some of the challenges of working in a startup. And if other people work in a startup, probably you might chime with some of the things I'll say here. And the challenges is that the fact that you need to execute on science whilst building the platform, the team, the facility, the processes, and everything at the same time. So executing and building at the same time is quite a challenge. But you got to really execute fast, otherwise you can't continue to attract venture capital funding. We also obviously have time and resource constraints compared to other big major players who can fund their internal R&D through revenues and just operate on a long-term scale. We also have the inability to have dedicated staff covering narrowly defined roles in traditional functions. So you end up having quite generalist, and everyone has to quickly learn to do all sorts of different things. And as I said, you do need to over-deliver to speed to attract funding. And it's a bit of a work and life balance issue because we expect so much from our employees and we end up having to wear so many hats at the same time. Next slide, please. But you can obviously turn a lot of that challenges into also opportunities, and you can find quite strength and good things about a startup culture that allows you to do some innovative things. These are listed here. In a startup, there's a bit of a sink or swim mentality. And that really focuses mind to make sure people deliver and do great science because, it's such a small team that everyone counts. At the very beginning, you could be like representing 20 or 30% of the company, and it really matters how you deliver. And you can see that, and people are very dedicated. And, we also have a high risk, high reward environment. And this tend to attract dynamic staff, not afraid to take ownership of decisions. And again, that's good too, obviously. And we have staff and academic founders with skin in the game, emotionally and financially, through, let's say, things like, it's like their little baby. If you created a company, it's so important to you. And if you joined it at such an early stage, you feel like almost part of the family. And obviously we provide stock options and the like that also give you the financial incentive too. And what's quite interesting is it ends up being quite a melting pot of cutting edge technology from academia and from industry, and it all gets mixed up. And it's quite it's quite an exciting environment to work in. And as I said earlier, staff do have to wear multiple hats, and that was a challenge. But actually, the opportunity there is that it allows us to actually obviously lower cost and keep it there. But also, every staff has such a wide breadth and understanding across the different functions, and that can actually speed up processes and give staff a level of understanding that's harder to get if you worked in silos, obviously. And decision can sometimes be made just rapidly because it's not that startup can make decision rapidly, not because everyone else is trying to be slow. It's just that, like, in a startup, one person represents so many functions that decision can be made up by that person. Just big R&D goes in certain directions without having to go through multiple rounds of asking different people, just because there's just fewer people. And finally, actually, this isn't a startup opportunity, but this is more just the fact that we're spun out of Oxford. It's very good to be close to a world-class university with staff to work with and a thriving biotech cluster. Next slide, please. And this is just acknowledgement slides on from our funders and then our directors, who's been very supportive and very great to work with. We have a highly respectable group of advisors and the management team, and obviously the wider team who all work together to help generate the results I have been able to talk to you today. And obviously, thank you very much to the Pesticide Manufacturers Formulations Association in India for inviting me to talk today, and the audience finally for listening to me for the last 20 minutes on our journey out more technology and the type of science we're doing. Next slide, please. And I think that's it, probably. Yeah. Thank you.
Thank you very much, Dr. Suji. Really very good and excellent presentation. I have learned a lot and hope you all. Your enthusiasm was really infectious, sir. Dr. Suji's presentation was quite informative and illustrative. As he mentioned, the mission of MOA technology is to discover safe herbicide with novel mode of action. His analysis of challenges and opportunities is going to attract new startups. Now, I request the participants to kindly ask 1 or 2 questions. Be very precise. Delegates may please say your name and company name. Delegates, please ask questions as Dr. Suji is online.
I guess is the question about the
Yes.
So if it says low hit in Galaxy, 0.3% resulting in change in final result. Very less possibility to hit. Is it trying to increase in Galaxy? Yeah. So I think for our side actually, 0.3% hit rate, we're quite pleased with it actually. And I think we won't probably try to increase the hit rate, because an interesting point is, if you have an assay that has a really high hit rate, it's not necessarily a good thing, because actually in the end, if you have a perfect assay, what you want is an assay, especially because at the end of the day, we're trying to make a field trial compound. The perfect assay in the world will just have 1 or 2 hits, very low hits, maybe 0.0001%, that is also active in the glass cell, that then finally becomes active in the field. And suddenly, effectively, that assay has managed to point out a field compound. Because if you increase your hit rate and if you have more compounds coming into the system and more fall through, you usually put your assay in order of cost, and it becomes a very expensive system. So my past experience in various other companies, and from what I've heard talking to our potential collaborators, because as startup we talk to many companies, our feeling is actually if you were to do random screening, even in bigger plants and relevant plants, we think actually the hit rates tend to be around 0.5% or thereabouts. So we're quite happy with our hit rate, and we probably will stay with that. And so long as you're operating in a random screening, diversity-oriented way, the hit rate would probably stay there. There are obviously ways to increase hit rates. Let's say if you once decide on a mode of action, or if you decide on a particular chemical type and start buying compound on a rationally designed basis. Now we can do that once we have a protein in mind through target and validated to be a herbicidal target and a chemical. And actually we've already started doing that type of work. But actually for those slides, I was showing about random screening on a diverse library. And in that context, that hit rate, I believe, is good, and we'll probably keep it there. Any other questions? So I'll read that out, and just in case people are not looking at the message bill, or not everyone maybe has access to looking at it. So question 2 is, can you predict any one chemical functional group that must be there in new generation of herbicide? Oh, that's a great question. I knew what it was. Yeah, I would tend to think that is quite difficult, I think. So, I think I'm a chemist by background, and I think every functional group is beautiful, each one of them, and you get the right functional group in the right context. And actually, when you put two functional group in the same molecule, they interact too, depending on how they're oriented and depending on how close they are. So there's such a wide variety of ways to make that functional group point into different directions. And it depends on the novel mode action you're going in particular, and it depends on the protein. So, proteins are made out of these amino acids, and they have their own functional group in various, randomly oriented way. And, when you're trying to find a novel mode of action and you're trying to, and every mode of action would have different proteins, it's kind of hard to predict up front which exact functional group you want. So yeah, I think I would tend to say, it's better to probably keep an open mind. Now, having said that, one thing that will definitely stay constant is things like, physical chemical property of the molecule. Let's say if looking for another glyphosate, which is probably like the holy grail if you can find, which is a systemic compound. Briggs published a seminal paper in the 80s where he said, where he shown the exact pKa and log P you need, the right balance to get a systemic compound, because every compound have to be systemic or at least bioavailable. So that will stay constant with old herbicides and new herbicides. But I think with regards to if you get as detailed as exact functional groups, I think there wouldn't be a rule there. I think it just depends on which protein you went for, I think. Next question, if there are any.
If no question, moving to the next presentation by Mr. Lawrence Midler. Before Lawrence Midler presentation, I would like to request our participants and delegates to kindly send your feedback or send your feedback in the feedback form, or send your feedback through the mail to the PMFI. Thank you. Now the last presentation, that is by Lawrence Midler, that is agrochemical molecules coming off patent in the next 10 years. Mr. Lawrence has worked in agrochemical industry for a number of years for a major contract research organization, undertaking preclinical registration studies in environmental fate and degradation, primarily for ag-wet molecules in development. He joined Philip McDougall in 2014 and he is now senior analyst responsible for analyzing intellectual property in agrochemicals, as well as tackling novel active ingredient research and the overall market for agrochemical products. Mr. Lawrence, please.
The topic of this presentation is agrochemical products coming off patent in the next 10 years. My name is Lawrence Midler. I am one of the senior analysts within the Phillips McDougall team here at IHS Markit. My background is in chemistry and contract research. Within Phillips McDougall, my main areas of interest are our intellectual property, chemistry and R&D analysis within crop protection. I'd like to thank the PMFAI for this invitation to speak at the Crop Science Conference and Exhibition. Just to add a brief disclaimer prior to commencing this presentation, every effort has been made in the preparation of this intellectual property analysis to ensure accuracy. However, the patent dates and positions are to be considered indicative only and may vary between jurisdictions. Just to provide a brief overview of some of the mechanisms within patent protection of crop protection products, patent protection is 20 years from the filing date at the National Patent Office. Typically, the time between discovery, which is effectively the priority date, and commercial launch of an AI is often around 6 to 8 years. However, this can be shorter or longer. The time lost to the registration process can in part be recouped through supplementary protection certificates, SPCs in Europe, and patent term extensions in the USA. In Europe, protection can be extended up to 15 years market exclusivity from the eventual country launch, up to a maximum of an additional 5 years. The term of an SPC depends on the date of the first marketing authorization within the EEA. SPCs are subject to EU-level regulation, but the decision to grant an SPC is ultimately made by the national patent offices. In the USA, a patent term extension can be used to extend up to 14 years market exclusivity from eventual country launch, up to a maximum of an additional 5 years. Lastly, regulatory data packs are protected through data exclusivity for a period of 10 years in Europe, North America, and some other jurisdictions from the date of first market authorization. This slide illustrates a simplified protection strategy for new crop protection molecules. As mentioned on previous slides, the patent protection for an agrochemical is 20 years from filing. Initially, the discovering company will file a composition of matter patent covering the AI. Assuming a typical launch around year 8, this would leave 12 years protection for the solo AI. If the company chose to apply for an SPC in Europe, this could theoretically extend protection up to 15 years of market exclusivity, or year 23. Most companies will also pursue a strategy of follow-on patent protection through a wide portfolio of patents covering mixtures, formulation technologies, synthesis, intermediates, and utilities. These are intentionally staggered to provide the maximum protection possible. In some cases, companies will review older research and choose to develop promising analogues for which the original composition of matter patent has expired. In these cases, the protection is mostly through follow-on patents. In all cases, companies can also seek to protect their market position through data exclusivity of the registration data pack, which in most jurisdictions runs for 10 years from first market authorization. This often creates a financial barrier to many smaller generic manufacturers wishing to enter a particular market or active ingredient. In the remainder of this presentation, we will look at molecules that are due to come off patent in the next decade or so, based on the composition of matter expiry. For the purpose of this presentation, SPCs and patent term extensions have been assumed to be enforced to the maximum extent allowed under regulation. Also, the analysis has been limited to the top 10 molecules by 2019 global market size. When looking at the herbicides, we anticipate saflufenicil will begin to lose composition of matter expiry sometime around 2023 to 2024. Pyroxylam is estimated to lose composition of matter protection sometime between this year and next, whilst aminopyrrolide is anticipated to lose composition of matter protection sometime this year. For insecticides, we anticipate chlorantraniliprole composition of matter protection to begin expiring sometime around 22 to 23, depending on the local market, whilst sulfoxaflor we estimate will lose composition of matter protection beginning in 2027. For the fungicides, the active ingredients in the top 10 mostly consist of SDHI fungicides ranging from expiry around 2024 to 2028. The other molecule, mandipropamid, is expected to lose composition of matter protection sometime beginning this year to next. Moving on to look at the herbicide active ingredients in more detail. Pyroxylam is an ALS herbicide launched in 2007 by Dow, with the key brand being Powerflex. Key crop outlets include the cereals market, whilst the AI is considered broad spectrum against a range of grass and broadleaf weeds. Key country markets include Canada, the USA, as well as Germany, Russia, France, and Spain. The AI is also effective on hard to control grass species at very low use rates with minimal crop rotation restrictions. Key mixture partners include with aminopyrrolide, the safener cloquintisette mexyl, fluoroacelam, clodinafop, fluroxypyr, and haloxyfen. From our analysis of follow-on patent protection, intermediate synthesis patents expire around 2038. The parent synthesis patents around 2035, methodologies 2030, and mixtures 2028. Saflufenicil is a PPO herbicide launched in 2009 by BASF and trademarked as Kixor. Key crops include soybeans, maize, sugarcane, cereal, orchard crops, as well as non-crop markets. Key pests are the pre-plant burn down control of a range of broadleaf weeds, as well as residual control against broadleaf weeds. Key country markets include the USA, Canada, Brazil, and Argentina. The AI is often utilised alone or in mixtures with glyphosate for burn down weed control, whilst the AI also provides foliar and residual activity against more than 70 broadleaf weed species. Key mixture partners include difenethamide, imazethapyr, saflufenicil, and pyroxysulfone. Follow-on patent protection appears to be to around 2039 for compositions, 2038 for utility, and mixtures out to around 2035. Aminopyrrolide is a pyridine herbicide launched in 2006 by Dow, with the key brand being Milestone. Key crop outlets include the pasture, rangeland, oil palm, rubber, fruit and veg, and cereal segments, whilst the AI is considered broad spectrum. Key country markets include the USA, as well as Germany, UK, Poland, and also Brazil within Latin America. Key mixture partners include with 2,4-D, fluoroacelam, clopyrrolide, picloram, cloquintisette mexyl, which is a safener, pyroxylam, fluroxypyr, metazachlor, metsulfuron, and propyzamide. Follow-on patent protection appears to be to around 2032 for mixtures and 2031 for synthesis patents. Now we will look at the two insecticides in the top 10. Chlorantraniliprole from FMC was launched in 2008 by DuPont and subsequently transferred to FMC as part of the closing conditions for the Dow-DuPont merger. The AI is known as by the trademark Rynaxypyr. Key crops include the soybean, fruit and veg, rice, cotton, maize, palm fruit, sugarcane, potato, and cereal markets, with key pests being a range of chewing insecticides, predominantly Lepidopteran species. Key country markets include Brazil, Argentina, the USA, Canada, India, China, and Japan. A key point to note about the molecule is that it's indicated to be particularly difficult and expensive to manufacture, with around 16 steps. Also, FMC is actively pursuing third-party supply agreements as a defensive strategy for the molecule. Key mixture partners include with abamectin, clothianidin, furometapyr, isotianol, gamma-cyhalothrin, imidacloprid, penflufen, indoxacarb, lambda-cyhalothrin, and others. Composition of matter patents begin to expire around 22 to 23, depending on the country market. Formulation, usage, and manufacturing patents extend protection to at least 2027 to 2028, depending on the market, while seed treatments are also protected out to around 2032. Sulfoxaflor was launched in 2012 by Dow, initially as Isoclast. Key crop outlets for the active ingredient include turf, soybean, cotton, cereals, and fruit and veg, with the key pest species being a range of sap-feeding insects. Key country markets for the active include the USA, Argentina, South Korea, and Australia. Key point to note is that the active is an agonist of the nicotinic acetylcholine receptor via a new subset chemotype for that particular class. Also worth noting is that the AI provides broad spectrum control at low use rates. Key mixture partners include with abamectin, flunisamide, lambda-cyhalothrin, spinetoram, bupropion, and methoxyfenozide. Follow-on patent protection appears to be to around 2031 for methodology patents and 2028 for compositions. Moving on to look at the fungicides. Fluxapyroxad is an SDHI launched by BASF in 2012 as Xemium. Key crops include cereals, soybean, specialty crops, and turf, and the AI is considered broad spectrum. Key markets include the Brazilian, US, and French markets, whilst the AI key feature is it offers both preventative and curative control against both foliar and seed-borne disease. The AI is marketed in a number of BASF mixtures, including with diphenylconazole and the recently launched methylfluconazole, which is Revysol. From analysis of follow-on patent protection, this appears to be to around 2038 for methodologies and mixtures, whilst 2037 for synthesis patents. Benzovindiflupyr is another SDHI which was launched in 2013 by Syngenta as Solatenol. Key crops for the AI include the soybean and maize markets against key pests such as soybean rust, powdery mildew, and a wide range of others. Key country markets include Brazil, France, and Germany, whilst it's considered a particularly good fit in the Brazilian soybean rust control market. The AI is marketed by Syngenta in a number of mixtures, including with azoxystrobin, picoxystrobin, prothioconazole, diphenylconazole, propiconazole, chlorothalonil, and metconazole. Follow-on patent protection appears to be to around 2038 for compositions and 2037 for synthesis patents. Bixafen from Bayer is an SDHI which was launched in 2010 as Xpro. Key crops include the cereals market against a range of key pests such as soybean rusts and others, with the key markets being within France, Germany, the UK, and other European countries. The AI has been launched mainly in combinations with tebuconazole and prothioconazole, but is also marketed in mixtures in the US with iprodione, flutriafol, and azoxystrobin. Bayer has also launched products such as Krypton Xpro, which is a mixture with prothioconazole and trifloxystrobin in Argentina. Follow-on protection till around 2034 through synthesis patents is indicated, and around 2030 for mixtures and compositions. Penflufen is an SDHI which was launched in 2012 by Bayer as Evergol, with the key crops being potatoes, cereals, oilseed rape, soybean, and cotton, against key pests such as Rhizoctonia, Fusarium, and other seed-borne pathogens. Key markets are North America and Japan. And also the AI is targeted at seed treatment usage specifically with a range of mixture products, including clothianidin, prothioconazole, metalaxyl, trifloxystrobin, cyantraniliprole, triflumetazopyrum, and isotianil. Follow-on protection appears to be till around 2031 for mixtures and 2029 to 30 for process patents. Mandipropamide is a mandalamide fungicide launched in 2007 by Syngenta as Revis. Key crops for the AI include the fruit and veg segment, including potatoes and vine, as well as other crops such as tobacco. The key diseases controlled by the AI are mostly omocyte diseases such as late blight, whilst the key country markets include Europe, such as Germany, the Netherlands, the UK, France, Italy, Spain, and Belgium, whilst also Brazil within the Latin American region. The AI is indicated for usage in foliar and seed treatment settings, whilst mixtures products include chlorothalonil, copper fungicides, cymoxanil, difenoconazole, dithianon, folpet, mancozeb, and zoxamide. Follow-on patent protection appears to be to around 2031 for mixtures, 2028 for synthesis patents, and process patents around 2025. So that concludes the presentation. Should you have any further questions, my contact details are on the screen. I'd like to thank you very much for listening.
Thank you very much, Mr. Larsen. This presentation was very useful. Mr. Lawrence has beautifully explained various aspects of patent protection in Europe and USA. Details like key crops, target pests, and key markets, along with use pattern of active ingredient going off patent is quite informative, and these molecules are likely to add in global generic market in near future. Thank you, Mr. Lawrence. May I again request the participants to kindly give us your feedback via feedback form or send your email to PMFAI. Thank you. With this, we conclude this conference, and I am sure delegates have gained ample knowledge from the experts having global reach. Thank you for your participation and patience hearing. We once again thank you our sponsors, Platinum sponsor, UPL India, Exhibition sponsor, Emco Pesticide Limited, Gold sponsor, Bharat Rasayan Limited, Silver sponsor, Agro Allied Venture Private Limited, Mahamaya Life Sciences Private Limited, Information Desk, Ambe Lab, Signage sponsor, Sulfur Mills Limited, Special Brand Promotion, Dow and Solvay, Show Guide sponsor, Best AgroLife Limited. We thank you, our content partner, Agribusiness Global, and media partner, Krisak Jagat and New Ag International. We thank you, our supporters too. With this, we hope to see you and your participation in ICSCE International Crop Science Conference and Exhibition in November 2021 in Goa, India. Stay safe and all the best to all. Patience hearing. Thank you very much. It's Ashna from PMFI. Thank you very much.